Okay, it is good to be back. So many ridiculous things have happened the past week. But once again, I can continue developing this. Okay, so let me first remember where we left off last time. So we implemented some button functionality to these levels. We got these kind of things consistent. Okay, so what else is there to do? What should we do this time? Write procedure to validate whether or not a given grid is a valid solution. This will be easy and a nice way for me to remember this project after more than a week off. Yeah, we'll add in undos when we start doing the dragging tile functionality. Okay, now would be a good time to do a README file. What else? Puzzle screen to menu button. Given that we've just created button functionality, this would be another good thing to do. Undo redo buttons. That will require tiles. We've at least got the outline for a main menu. Okay. Let's start off with this. And so let's also change, say, the background color when one of these things actually has been solved. Okay. I have like an hour and a half to stream, so this should be possible to do within this time. So yeah, let us recall what's happening in the main loop. We set up this window. It's this import font from embedded file. I think we can actually get rid of this. Right? Yeah, we're not using this anymore. We're doing our own QOI file embedding. Yeah, we can get rid of all of this. And then get rid of this. Load at runtime the bitmap. Yep, do all of this. What's this magic constant alert? Each character in the bitmap has an X. Okay. To do transfer bitmap info onto test.io using image draw rectangle. Did we not do this? I feel like all the bitmap stuff is rendering. Okay, we can clear this out. What's this one? Numeral images gen image color 2020 debug. Yeah, that's fine. Get rid of this. Okay. So like oddly, like a lot of stuff happening in main before we even get to this loop. But actually it's not too much. I don't think there's any need to factor this out into anything as of yet. Okay, and then the actual main loop. Calculating the geometry, processing the input state, and then rendering. So at what stage in this should we check to see if the screen is correct? Probably after the grid is correct. Probably immediately after mouse and stuff has been determined. Because I think, like, for instance, if on the previous frame the player has just like let go of some tile they've dragged on and it is correct, then in the next frame, when we're actually drawing the snapped tile into the position, we also want to immediately highlight that it's correct. And so, yeah, we should then kind of do this. Like this is a state that we're updating, so this is the place to do it. So let's add this down here then. Do hover / click logic for the type of screen the current frame is on. Okay, and we're actually breaking this up into separate parts. Okay, so really, we want to switch this up in this process puzzle hover clicks section. Determine whether the mouse is hovering on either of the arrow buttons. Okay, after this. Why is all of this stuff here? Change from the main menu to the puzzles when the left mouse is clicked. Yeah, we can just get rid of all of this, I think. Current handcrafted level index. We're switching all of this. Okay, away that goes. Okay, so now we can actually do check to see whether or not the current grid represents a solved puzzle. Okay, and then actually let me just like adjust this a bit. Okay, so this function should be really simple to write, like this, and this is a bona fide function, not a procedure, since the output would be the same regardless of what the input is. So we want to just check that numbers from 1 to 4 appear in every row, appear in every column, and appear in every 2 by 2 grid. I check to see that every row, column, and 2 by 2 quadrant contains the numbers 1, 2, 3, 4, contains, yeah, we can say it contains the numbers. It contains, yeah, each of 1, 2, 3, 4 exactly once. Okay, and then, so how are we going to do this? So we need to, let's check out what our grid data type stuff is. Is it struct grid? No. So a grid is just, yeah, an array of 16 tiles. And so, what is an easy way of doing this? Like a really crude and slow way, and I think unnecessary way, would just be like sorting each row, like copying each row, sorting it, and then checking to see if it's 1, 2, and 4. But this is really unnecessary. I think it's literally just checking, are all of the entries different to each other? But when I say different, what I really mean is for both, once we consider something like a draggable tile and a fixed tile to be the same, if they have the same number, check that all of these are different, and check that all of them are non-zero. And then, yeah, if all of them are, so that's the first thing to check. If the grid does have an empty position, it's clearly not solved. And then if it doesn't have any position and everything is unique in all of these rows and columns, then in order for everything to be unique, there need to be some permutation of 1, 2, 3, and 4. So then it's solved. Yeah. So we first check that that the grid is not empty, or rather, the grid does not have an empty tile. From memory, these should be represented by a 0. Definitely somewhere I annotated what these tile numbers are. Where did we do this? I think we did this in like the levels.txt. Yeah. Okay. Yep, so for these handcrafted tiles, we're just representing all of them like this. And then how does the part of the code work where we loaded in these levels? Levels.txt. We made something called level parser. How does this stuff work again? Level file name, level string data. Okay. And when we are creating this current level data, okay, we're casting all of these to 1, 2, 3, or 0, and none of these are fixed at this point. Okay. Yeah, because the idea is that since we're using assigned 8-bit integers to represent each of these tiles, and if it's 0, it represents an empty tile, and then if it's either positive or negative, it represents a tile which you can drag or a tile that is fixed. I have forgotten the convention though. So we need to look this up. If I've even documented it. And I have done it here. Okay. Positive number represents a fixed tile. Negative number represents a selected tile. Right, because in these levels that we're starting off with, that we're loading each thing from, these are going to represent all of the fixed tiles, which is why when we converted them, we just like casted them after doing the ASCII. We didn't multiply them by -1. Okay, but for the other ones, for the movable tiles, they will be like -1, -2, -3, -4. Okay, so then, okay, we'll do this part soon, but yeah, recall that fixed tiles that for positive n, the tiles n and -n both represent fixed and draggable tiles with the number n respectively. Okay. Okay, so first, let's check this does not have we're doing this part. Check that the grid does not have an empty tile, so we can just say for tile in for what's the current grid? basically for the tiles in the current grid. So let's say const non grid non grid full is equal to, there's some way of doing this in Zig, I'm just going to do it the easy way. Non-empty is equal to grid full is equal to, okay, true. And we're going to iterate through this grid. For current grid, we're going to say grid full is going to equal grid full and whether or not the tile is equal to 0. And then, yeah, if any of these tiles, hang on, not equal to 0. And yeah, if any of these tiles is 0, then the entire thing will get ended to false. There's some way of doing this with return and Zig. It's readable like this. Okay, but this is assuming the current grid is actually called current grid. How is this part working? How do we render the grid? So we're rendering these puzzles. And then, oh, we're getting the grid via this. Okay. It would be useful getting this as a, since in this part of the code we are going to be updating the states, the state, we should get like, we should just get a pointer to this. But also, given that this part of the procedure is called process puzzle hover clicks, I want to move this to like something else. Okay, let's adjust this first. So process. Yeah, so this process input update state. Yeah, we need to do the detection button logic for the buttons. Then we also need to just say, I guess we can do it here. Update. And we call it like process, like grid dragging clicks. Okay, we need to just turn this, we need to make a name for something that is just going to compute like we've got the hover button logic, and then we've actually got the tile dragging logic, and then I kind of don't want to lump this, checking to see if it's true in this. I think it makes sense to just keep this separately actually. We can just say check if grid solved, like yeah, check current grid solved. And I think that's actually all we need to do. Okay. Okay, so let's do function check current grid solved. Okay, so now we can actually say stuff like, since we're just checking if this grid is solved, we can just take a constant value to this grid. So we can say this grid is going to equal where was it? This is really the render one I want. This one here. We're taking the current handcrafted levels, and then we're taking the level index. So now we can just say for grid, do this, and then we're going to want to update we're going to make a global, we want to make a global to indicate if this grid is solved or not. And yeah, putting this in the game mode makes sense, I think. Or maybe it actually makes sense to package this in like the level data instead, and just like add in some boolean to indicate whether a particular level has been solved or not. Like this function is fast, and this function will be fast enough that we could almost just compute everything dynamically and just like every frame check the status of how many levels have been solved immediately. But from an organizational point of view, it might be easier just to keep track of when a level has been solved in some kind of memory or data. I'm tending to yeah, I want to do the store this as a boolean somewhere. Let's figure out a place to solve this. A place to create this. Okay, so these handcrafted levels are what? We should really state what the type of these are. Let's go to the class levels, level parser. Okay, I see the problem now. So you can just say, yeah, parser dot number of levels equals end of type. Grid. So then we want to we can just create a boolean with number of levels in it and just store whether each of those are solved or not. So let's go back to this. And yeah, we can say here, it's a bit weird that I've kind of split this up. So we're importing this up here. Alright, because this is like this is the one that we're going to reuse when we reset a level. This other one is then just, this other level version is just the copy of it. Okay, I get that now. Okay, so let's do maybe like handcrafted levels solved status. And then we want this to just equal an array where everything has been set to false to begin with. So maybe I can say this is then this parser. Oh, I don't even need to say parser. This is of type the number of handcrafted levels, the length of this, times the of type boolean, and we'll set all of this to be false. Okay. And then yeah, basically we just need to update the specific index of this when yeah, for each time that we check this, when we're checking to see whether these are true or not. So I forgot the shortcut. Process. Okay. Now we're back here. Now we can say that the handcrafted levels solve status with the current handcrafted level index is equal to slight possible bug maybe. Okay. If on the mouse click, this is fine. I was gonna say, if on the mouse click someone said to go to the previous level, then when we get to this logic, we're going to be evaluating this on that previous level, on the next level. But then this is exactly what this is doing here. It's going to update the current one, and this is fine. It's not an issue. Okay, so yeah, we now just want to set this to basically the result that we're going to get. Let's set it to false to begin with. Okay, so yeah, so we're checking to see if this does not have an empty tile. It kind of makes sense though to just set this to false and exit the loop if we do come across one that is 0. So maybe it's actually better to write this as saying for everything in here, that's fine, this is okay. We'll just do now, we'll do an if here. If grid, if it's not the case that the grid is full, then we're going to just say this handcrafted levels is false. And then we want to exit this basically. early. Maybe it would make more sense to actually have something that have a function that will just return a boolean and then kind of set this once. I'm kind of opting for that more actually. So yeah, if down here instead we actually move this here. Then it's kind of clear from this higher logic what's happening. Like, small decisions like this add up, just when I'm thinking about this. Longer than I want to. Okay, we're gonna go back on this. We're just gonna change this, but now instead of check, it's just gonna be called update. Update current grid solved. This makes it clearer. Now it's clear from the name of this procedure function. This is now a procedure. What it's doing. Okay, and then we're just like returning from this. Okay, so assuming then the grid is actually full. Now we want to check this condition. So now we want to say for 0, for indices 0, 1, 2, and 3. Why is this on that side of the screen? Now we want to go through. Yeah, let's just create some like booleans representing if like the rows, the columns, and the quadrants are fine. So we could say a column's unique. Then we could say the rows unique, and then finally the like the quads unique. It would have been faster for me to do that manually, whatever. Okay, and then yeah, let's iterate through all of the rows first. So actually we want a double loop here. Actually, maybe we don't. Yeah, I don't think we do. So, yeah, okay. Okay, so let's just say, let's just give all of these names to make it easier. So we can say tar1 is now grid 4 times I plus 0. And likewise, we'll do T3, T4, and that's fine. 1, 2, and 3. And now we just want to do a really simple Boolean expression. So now we want to say calls unique equal rows unique equals rows unique, and if all of these things are different from each other. Okay, let's see. So we have to do for choose 2 comparisons. Wait, for choose 2 is 6. Yeah, 6 would be fine. Just to make this easy to write, why don't we just say unique? The compiler will get rid of it. We'll optimize all of this. So we're just now saying, I want to say something like the following. This is not equal to this, and T1 is not equal to T3, and T1 is not equal to T4. And then T2 is not equal to T3, and T2 is not equal to T4, and T3 is not equal to T4. Okay. We need to convert all of these numbers because they're potentially negative to like the appropriate absolute value. How did we do this in, we can just do int cast, right? We definitely did use an absolute value function in a previous project. Where is it? Or even in a current project. Okay, there's there's absolute value floats. Oh, it was this one here. There's abs cast in main. Abs cast. Okay. We strictly don't need it to be casting, but that's fine. The compiler will figure out that we're not actually casting to anything. So we'll go, yeah, T3 is, let's actually make this, yeah, let's just make it clear that all of these really should now be positive. Standard.math, oh, this is macro time. I sense the macro. F3 standard.math.abs cast down to me. I really like Emacs in moments like that. Okay, and now I've got all of those. We have cast them all. So now we say, yeah, the rows unique is now just rows unique and unique. And then at the end of that, if all of these are unique, rows unique should still be true. Because yeah, if any one of these are the same, the entire thing will fail. This will now be a false. This will now be a false. Okay. And then we just do a similar thing, but now with the rows. I will not copy past to this. Calls next. So we can say for 0, why don't we just call this a different variable? Now we want to say, we will copy past to this. We now want to iterate over the row. So now we want to say, all of these parts are now constant. J, oops, try again. J, and then, hey Chandu, yeah, there's button making stuff will appear. Oh, I forgot to rename the name of this stream. I should fix this. Yeah, because I'm not actually doing button stuff now. I'm doing logic kind of stuff. Where's the? Because I'm not actually doing button stuff now. I'm doing. Where's this button to do it? Is it this? Create a dashboard. Stream manager, is this what I want? Go away, just allow me to rename this Twitch. Okay. Oh yeah, it's certainly not late night. It's snowing outside and it is sunny. Daytime Sudoku game logic. Sudoku logic. Okay, this is now more representative of what we're doing. Sorry. Okay, sorry, Chadu. But yeah, currently this basic Sudoku game I'm making looks like this, and I'm currently just detecting whether one of these puzzles has been solved or not. Because yeah, there is a long list of things to do before this is finished, but each of these is really tangible. Okay, so now we're iterating over these, iterating the columns, checking everything in every column is unique. And so now I want to say, we want to say unique is equal to basically exactly the same thing. I can just copy this. But these numbers here will require some care. So we want all of these to be multiples of 4. So we'll start off with 0, 4, 8, and then 12. And then, yeah, and then we got that, and now we just say calls unique. Oh yeah, so these are some important questions, Chandu. Why am I doing this? Several reasons. The first is just to give myself some more experience with Raylib in 2D before I start the next project. The next project I am really passionate about, and I'm super excited to do it, but I need to get this done first. The next game is going to be a 3D game made from scratch in Raylib, just involving, it's going to be a puzzle game involving cubes. It's going to be like a maze with cubes, which when you see it in action, when people see it in action, they will go, this is cool. At least all of my friends who I've shown stuff to are like, this is cool. Okay, but before I get to that, one, I need to finish this. Two, I've had some ideas for a while with some like grid-based puzzle games. I started working on a prototype of one in Odin, and then the Odin language was just, it got to a point where I was really frustrated with it. I do love so many of its features, but some parts were just grating, and so I thought this is a perfect time for me to instead try out Zig, and I've been loving Zig so far. And so by kind of building this base of this, I'm using Zig, the Zig programming language. And so by using, and the other one I was using was Odin. These ones here. And yeah, there is a very fond place in my heart for Odin. I'm just finding so far that for game dev, Zig is actually better. This is my take. Many people have different takes. But yeah, and so if I just get a working model of a simple Sudoku working, then it will be very easy to transition this later to this far more expansive grid-based puzzle game that I want to do at some stage. But yeah, it was just when I started working on this other one in Odin, the scope just started to kind of just blow up completely. Like I started off thinking, oh, this other game will be like 2 hours, and then it was quickly becoming apparent it would be like 10 hours, if not 20. And I was like, I need to just stop this immediately and continue just building like small things. Research, explore a large range of ideas, and then before I commit to a big one. So yeah. What graphics API am I using? So I'm using Raylib. So Raylib itself is calling OpenGL under the hood. So for instance, if I go to, okay, it's probably easy if I just literally open it up here. So I'm using Raylib 5, and then in the source code of Raylib, if I go to the parts in here that do the actual drawing, like, what would the drawing be? It's going to be calling OpenGL. So if I do like Raylib 5, if I type in like GL, yeah, right, you can see here, okay, what's like a common GL? Like GL, draw triangles, like I'm absolutely certain it's GL. This is actually the first time I'm looking though. Maybe I'm wrong. But yeah, it's calling GLFL which is the C library to the spawn windows for which to draw GL commands on, and then where's some of the rendering stuff? Oh yeah, RL vertex 2F. Yeah, that looks like Raylib. Yeah, Raylib stuff to me. So, yeah, what is the software you're using to search stuff? Oh, it's a utility known as Bear grep. So, not Bear Grey. This one here. It's just for Windows. Another side. It's kind of old. Another possible side project in the future is writing a version of this, but in Zig. I'm kind of not tempted to do that though, because someone is already generalizing this in the handmade community. For instance, if I do like handmade Seattle last year, there was a project known as, it's basically a file explorer which is like 1,000 times better than Microsoft Windows file explorer. So for instance, say I was to open up this project in the Windows file explorer, like this thing here. Let's just currently do a comparison between like this program and this Windows search here, right? So let's say I'm searching. Okay, this will not be a great. Actually, maybe this could be a great example. Let's say I just search. I'm searching header files containing the word yellow. Immediately it did this within a second. Okay, now let's try searching yellow in here. Okay, it also did it kind of quickly as well, but now it says no items match your search, even though it's appeared in here. Okay, problem number one. But where is it? Have I tried like Power Toys? A bit. I have sometimes. I have used that before, but just for the color picker. But let me show you this this project. Which was it? It was a demo. Disk Voyager. This is it here. Okay. Disk Voyager. Okay. Windows. Okay. Yeah. This thing here. You can sign up for like the alpha or the beta. I guess we can like watch this on YouTube. But yeah, I'm using this bear grep program at the moment. However, basically as soon as this comes out, I'm probably going to be switching to it. So like it has this feature here which is also in Power Tools. There's Power Toys, like battery management files. But then it also has remappable hotkeys. You can just like change a lot of the colors. There's also like a graph search. Yeah, basically it's like this functionality but in the file explorer. But yeah, until this software comes out, yeah, I'm happy using this for the moment. Okay. So yeah, Chandru says, I'm interested in building distributed stuff. I work with high-level languages at the moment, distributed systems. Oh yeah, I basically have zero experience in doing distributed system stuff. Yeah, I think there's a lot of conceptually really interesting problems, I think, that's to be found in that. But yeah, my current like passion projects at the moment is like, yeah, it's kind of like creating new puzzle games that have like a basic core idea that can be used to explore a wide possibility space. Okay. Yeah, let me just get out of this. Okay, actually, wait. I shouldn't be trying to compile it yet, since we're still in the middle of writing this function. What's happening? Anyway, okay. So yeah, this unique is now calls unique and unique. And then we just want to do the quadrants. So now we want to check. Yeah, I'm using a standing desk. I just prefer to stand. And yeah, I did have, like last year or the year before last year, I was sitting down for a lot, and then I just started getting a lot of back pain. It got really bad one week. Like one week I was basically barely able to move, and it was a bad time. I found that since getting the standing desk, I've had zero back pain problems, so I prefer using this. Okay, and then yeah, for the quadrants we want to just yeah, we want to just check if like 2 entries and then 4 plus those 2 entries are different, and then we can just, I think, move that index up as well. So we can also do a for loop for this. Yeah, for going across this way, we do more copy pasta like this. But now we want to start off with, let's see, what are we iterating over? Like 0, index 0, index 2, index 8, index 10. Okay, that's kind of weird, so let's actually write those out. So index 0, index 2, 8, and 10. If the compiler whinges at this, we'll figure that out later. And then k plus 1. Then k plus 4, and then k plus 5. And I think these should correspond to all of the appropriate quadrants. Yeah. Okay, so then we want to say unique. Just copy the same thing again. And then quads unique. Oh yeah. Chandru says, yeah, when I sit I get a lot of leg pain, I hate it. Yeah, I also got some leg pain in addition to back pain. And like since I like, I was gonna say since I do a lot of running, it's more like since I regularly go for runs. Yeah, I was finding this annoying as well. But yeah, I find this has gone away with the standing desk as well. Quads unique is equal to quads unique and unique. Okay. Okay, so now we've like done all of the checking to make sure all of these are unique. And then, so now we should be able to just set this to the result. So now we can say this overall result is now going to be are these rows unique, and are these columns unique, and are the columns unique. And then we can just return the void. Okay, let's check that this is working. We can check this is working by going to our level file again and creating something that should actually be recognized as complete. So let's kind of fill this one in. 1, 2, 3, 4, 4, 3, 2, 1. This level 4 here should be fine. And now let's change the background color depending on whether depending on this kind of status. So let's go to the render part, and when we're doing this, yeah, we want to change part of this. Actually, let's just change, say, like the color of the grid. What is happening with my monitor? Come on. Like on my end, things are, the monitor's like weirdly changing. It's taking up the most CPU. Okay. So why are we at draw grid tile options? We've done this. Did we not use this tile geometry struct? Here we are. Okay, this part's done. Okay. Okay, where's the part where we're drawing these vertical and horizontal grid bars? And this part is not just drawing the vertical grid bars, this is also drawing the horizontal bars as well, from memory. Yeah, for one of them, the horizontal offset is not changing, so that must be the horizontal part. And then for this one here, the vertical, the vertical offset's not changing. Okay. So for all of these, we want to change this grid bar color depending, this is just completely temporary. Change this grid bar color depending on when we get on this previous result. Okay, so where did we set this from? Oh, this is like a constant. Okay, let's make this temporary. This is just to indicate if it's working or not. Say const grid bar, let's call it bar color, is equal to if solved, make this the grid bar color, else we'll make it say like yellow. And then yeah, this solved here is what we just set. Oops, that's not where we are. What's the name of it again? Okay. If okay, why don't we do it? Okay, solved is equal to this handcrafted level solve status, current handcrafted level index, and then yeah, if this thing is solved, set it. Okay, compiler error time. Okay, 393. Hey, wait. Oh yeah. Oh no, I did it again. I forgot to put void. Let's go to our tally. Oh, we're now up to 4. Okay. Oh, and we're up to 5. 393. Oof. 407. Yeah, expected this after return. There should be some way to do this in Zig, right? Like if you're not returning if your procedure isn't returning anything, you just want to like exit it early. This is going to error. Okay, no, that's fine. 412. Verb. Ooh. Wait, what syntax am I using here? It's not necessary. Okay, this part did error as predicted. How do we deal with this? Do I just need to say what this is? So this is a collection of 4 view size. 443. There's no need for a return there. It's clear what's happening. 494. Unused local constant bar color. Oh yeah. Oh, okay. Because we want these ones to be our color. Okay. Error. Number of levels is not passed to public. Understandable. Okay, I added this in just for it to be more readable, but maybe it's best left as a comment. Yeah, the level data has type number of levels, number of levels, 100. Oh, no, 46. The index 3 outside of array length 3. Oh, right, because we added a different level, but we didn't update that piece of information. Expected type 4 bool, found bool. 1, 2, 1. Yeah. There must be some way of doing this in Zig. I need to. Should also wrap up the stream in like half an hour. We'll get this. We will solve this. We'll solve this to do today. How do we? There's some way of doing this. Let's just figure it out now. This is certainly not the first time this issue has happened, and it is certainly not the last time it will either. I kind of want to break at the LLM. How do I initialize an array in Zig with a constant? Like, I want every entry to be the same. The question is, how do I do that? This is, yeah. We could do this. Yeah, we could say this variable is going to equal yeah, the constant array of false, but multiplied by handcrafted level length times. Oh, wait, okay. Okay, compiled. Oh, and the colors, it's working. It's working. The colors are around in the wrong order, but that's great. I will take that. So now we want to go back to render, and this bar color is if it's solved. If it's solved, we want it to be yellow. Else, make it this bar color. Okay. None of those are solved, and this one is great. I just want to check to see that this is fine. Let's just do some like basic test to check that. Actually, when I say like test, we could start using the. We could maybe write some tests with this using this like Zig build system test framework stuff. This is something that I have read about, but I haven't got much experience using. Before we do that though, we should just save this and push it to GitHub. I am curious about checking this out though. So if I update current grid solved function, like it would be, like this logic is simple enough that I'm confident that it's working just based on this current test. It would be nice in future projects though, especially with regards to this, to instead of wrap this up in, instead present this as a function that just given a grid or given a pointer to a grid, okay, it can be a grid in this case, everything's I8, just a grid that does output like a boolean, like similar to the thing I wanted to do before I changed my mind. Because then that would make it really easy to test, to check that the logic is actually working. I want to think about how to do this now and just get this in now so that in potentially future projects where there's a different rule system instead of the Sudoku system for this grid, which was definitely the case in my prototype, it'll be really easy to just run some tests to make sure the logic is working. But before we do that, let's save this. Yeah, we'll save this. Clear. I cannot wait for Abner's terminal. I need it, Abner. I need terminal quick. PowerShell is so bad. Every other option is so bad. Okay, what have we done? We have, yeah, we added in this, like, we basically just got the grid logic and cleaned up some stuff. Git add, git commit. Yeah, wrote logic to detect whether or not a grid has been solved. Okay. And yeah, she's got to push that. Okay, all on GitHub, great. So now we can get rid of this. But I'd rather just, yeah, collect this in. I wanted to start writing this logic as something that can separately be tested, because that's the skill I want to incorporate in future projects. Okay, and okay, we have like 15 minutes. It should be possible to do in 15 minutes. Okay, and then puzzle screen to menu button. Yeah, I think this is the thing to work on next time. But for now, let's wrap this up. So we needed to do the update current grid solved. Yeah, let's change this. So we can make this really simple. So we've got this grid, and then we can simply do grid solved equals is grid solved, and then we'll just pass in the grid. It's small enough. It's not going to be a text on memory. And then I say this, but like, yeah, it's easier this way instead of doing stuff with pointers. And then, like, yeah, this is literally just like 4 floats. Like, people pass in 4 floats to functions every time. It's fine. And then we just want to do this part. Handcrafted level solve status is equal to grid solved. And then that's kind of it. End of that function. So then let's do function is grid solved. And this is now going to take a grid of type grid and return a boolean. And I don't think much should change, but now we can actually return, prematurely if something has failed. So so in particular, for this part here, we can just say I wanted to just say something like break if it's true and then immediately exit, but we can just do that here. We can just say if not return full, return with a false, and then that will exit early if it is empty, and then everything else should just say we are now just returning this. We can even do these could we do these sequentially? I don't think it makes sense to do these I think the logic is clear enough as it is. I think it should be fine. Okay, zig build, let's just check this still compiles and works as expected. Yep, it's fine. So now let's write some tests that deal with this function. Is grid solved? From memory, we did have some test grid somewhere, and good thing I commented it out instead of getting rid of it for exactly a case like this. So now we want to say we want to just create some tests that some grids just for the express purpose of testing this function. So maybe I should actually move this to a different file. I think logically this makes sense. Okay, we'll do this. So let's do something called like grid logic.zig. And copy in this here. Let's say constant standard equals import standard library. We're going to have to import this stuff, this types, and then everything else should be really self-contained. Like update. Let's move this over. We now need to make this public. We now need to import import this and give it a name. So why don't we call this like logic dot, maybe like glogic for grid logic. Actually, just logic is fine. Okay, got the parser, the shapes, the button. Logic is equal to import grid logic.zip, and let's just check if this still compiles. And works. Great. So now we can start writing some specific tests for this. So let's write this. Yeah, test to check that the grid logic, that the Sudoku testing logic works. So Emacs. Why is it like inserting that instead of a blank? I don't know. Anyway. So let's do, say, like, I mean, grid 1 is a perfectly fine example, I guess. Let's have this, let's have another grid where this time we fill it in. I feel like we should be assigning more specific names to these grids to just actually describe what's going on. So what if I do like, this is a grid with an empty tile. Grid with empty. For this one here, we can say this is meant to be a correct grid. Grid correct 1. Why don't we now do a grid with a repeat? So let's say we have. We can make this boring. 1 1 1 1 1 2 2 2 and this is we'll call this a row repeat. Likewise, we could do a column repeat. Ooh, I think this is macro time again. 1. Ooh. Yeah, 1. What's happening? 1 2 3 4 enter, and then put this here. Grid call repeat equals grid. Here. Anything else to check? Why don't we check that the quads fail even if everything else is fine? Let's do grid quad fail. How should this one be designed? So we still want each of the rows and columns to be unique. We just don't want the some of the quads to be correct. Okay, so if we instead did like 1, 2, 3, 4, and now what if we did like 1, 2, 4, 3, and then 3, 4, 1, 2, 4, 3, 2, 1. This fails that. Okay. Okay, so now we've added in these, now we have the data for the test. Let's actually do these tests themselves. So how do we do this in Zig again? Zig test. Okay, so we need to, that's right, we need to like declare things as a test with the specific syntax. Test, I can literally call it like grid with empty. And then we want to say, is grid solved? So standard.testing.expect is grid solved for our grid with empty. Let's flip the screen this way. Grid with empty, and we want this to be true, false. Likewise, we want to do I don't even need to call this a separate test. Let's just call this grid logic. Or maybe just like is grid solved logic. So grid with empty, the grid correct one. Let's actually lead with that one. This really should be true. And then yeah, if it's empty, it's false. If we have a row repeat, it's also false. If we have a grid column repeat, false. And then if we have a quad fail, it's also false. Okay. Let's check this is working. So now we want to say, is it like Zig test grid logic? Zig. Okay, seems to be working once we actually get this compiling. So 84. Function declared here. Expected 1, argument found 2. Oh, because we need to pass in a boolean. Is there another way where we pass in concrete values instead of a boolean? Not that it makes too much of a difference. But logically I'd like it if it's just like, this is the computation, this is what we would expect from the computation. Compare the two of them. whatever, we'll just make them equal signs now. What's this? Error is ignored. Huh? What's happening? Let's just, given that we did some tests before in the QRI parser, let's just check that part out. We did it at the bottom from memory. Okay. How did this stuff work? Oh, it's called expect equals. Okay, and then we need to put a try in front of it. Okay. Expect equals. Expect equal. Yeah. Macro time. Oops. Okay. Let's try this test now. Forgot the tries. That is okay. Wait. Great. It passed. Brilliant. So yeah. Now we tested those, and I think it's good to commit this, right? Zig build run. It's detecting whether this is true, detected whether these were false. For these very concrete examples, it detected that these failed as well. So yeah, let's reorder this. It makes no sense to have these in a different order than this. So great. Okay. Let's add these. Commit them. Yeah, added some tasks for moved grid logic to separate file, added tests for grid logic there. Okay. Yeah, I'm happy with this progress. At least for this midday session. I want to do some more tonight. But yeah, I guess so. Yeah, probably tonight then it would be good to work on adding in another button just to take us back to the main menu. And then given that before this stream we did button stuff, finally add in a readme file for this project. And then, yeah, and then we can get onto the main feature, which is the dragging the tiles. And then after that, most of the programming of this project, I think, will be done. And it will just be the design part, which is always fun, if not the most fun. And, yeah, and then after that, I can choose colors, get this game out, and then I can begin work on the super fun cube puzzle game. But yeah, thanks for everyone who dropped by, chatted, and I'll see you in the next one. Bye.